All right, buckle up, friends. It's your veteran YouTube guide back with a magnifying glass and a healthy dose of skepticism. We're going to delve deeper, expose more, and hopefully arrive at a more satisfying conclusion about this RTX 5080 situation. Get ready for a roller coaster of tech talk. Let's not beat around the bush. The initial reaction to the RTX 5080 has been lukewarm at best. The whispers, the rumors, the pre-launch hype all pointed to a card that was supposed to be a significant step up. But now that it's here, in the hands of reviewers and early adopters, the narrative has shifted. It's not a bad card, per se, but it's definitely not the revolution we were hoping for. We're talking about a company that used to redefine the landscape with each new generation of cards. Remember the jump from the 900 series to the 1000 series? Mind-blowing. The RTX 2000 series introduced ray tracing, a game changer, even if it was a bit rough around the edges at first. And the 3000 series, well, let's just say it was a golden era for performance gains. But something's changed. The pace of innovation seems to have slowed. The gap between generations is shrinking. And that, my friends, is why the RTX 5080 feels underwhelming. So let's get down to brass tacks. What are we actually looking at here? The RTX 5080, as we've discussed, shares a lot of DNA with its predecessors, the 4080 and 4080 Super. Similar core counts, clock speeds that are within a hair's breadth of each other, and a memory bus width that's essentially unchanged. The big talking point is the move to GDDR7 memory, promising faster bandwidth and improved efficiency. But the real-world impact of that faster memory, at least so far, seems muted. And then there's the VRAM. 16 gigabytes. Sigh. Look, I understand that for many gamers, 16 gigabytes is still enough. You can play most games at 1440p with high settings, and even dabble in 4K with some compromises. But we're talking about a high-end graphics card. A card that's supposed to be future-proof. A card that's supposed to handle the most demanding games and creative applications for years to come. And let's not forget about ray tracing. It's becoming more prevalent, more sophisticated, and more VRAM hungry. Games like Cyberpunk 2077, with all the bells and whistles cranked up, can easily saturate 16 gigabytes of VRAM at 4K. And as games continue to push the boundaries of visual fidelity, that VRAM requirement is only going to increase. So, what's the deal? Why is NVIDIA seemingly holding back? That's the million-dollar question. There are a few theories floating around. One is that they're simply constrained by manufacturing limitations. The chip shortage of the past few years has had a ripple effect throughout the industry, and it's possible that NVIDIA is struggling to produce enough high-end GPUs to meet demand. Another theory is that they're strategically segmenting the market. By releasing a relatively modest upgrade with the RTX 5080, they can push consumers towards the higher-end RTX 5090, which will presumably offer a more substantial performance leap. It's a classic case of planned obsolescence, designed to keep you upgrading every year or two. But perhaps the most cynical theory is that NVIDIA simply doesn't need to innovate as much as they used to. They're the dominant player in the GPU market, with a commanding lead over AMD. They have a loyal customer base, a strong brand, and a suite of proprietary technologies like DLSS and ray tracing that give them a competitive edge. Why push the envelope when you're already at the top? Which brings us to the elephant in the room, DLSS, or Deep Learning Super Sampling. NVIDIA has been touting DLSS as a game changer for years, and to be fair, it's a pretty impressive technology. It uses AI to upscale lower resolution images to a higher resolution, resulting in improved performance with minimal visual impact. But here's the thing, DLSS is not a magic bullet. It's not a free lunch. There are trade-offs involved. Visual artifacts, blurring, ghosting. These are all potential issues that can arise when using DLSS. And while NVIDIA has made significant strides in improving DLSS over the years, it's still not a perfect solution. And let's not forget about latency. DLSS adds input lag, which can be a major problem in competitive games. The more frames you're generating, the more input lag you're introducing. And in a fast-paced game like Valorant or Counter-Strike, every millisecond counts. So, while DLSS can be a useful tool for boosting performance, it's not a substitute for raw GPU power. It's not a way to magically transform a mid-range card into a high-end one. and it's certainly not something that should be used to mask the shortcomings of a new generation of GPUs. Now, I know what some of you are thinking, but NVIDIA has to use DLSS. It's their technology. Why wouldn't they? And that's a fair point. But I would argue that NVIDIA is relying too heavily on DLSS to prop up the performance of its new cards. They're using it as a crutch, a way to avoid making the kind of significant architectural improvements that we used to see with each new generation. Because honestly, it's a little insulting that the main selling point of a brand new high-end graphics card is its ability to run older games with slightly better performance thanks to AI upscaling. Shouldn't we be expecting more? Shouldn't we be demanding more? All right, let's dive into some more game benchmarks. It's time to see how the RTX 5080 stacks up against the competition in some of the latest and greatest titles. Again, we're cranking everything to 4K, maxing out the settings, and pushing these cards to their absolute limits. Alan Wake 2, known for its stunning visuals and demanding ray tracing effects, Alan Wake 2 is a true stress test for any GPU. The 5080 averaged around 60 FPS with ray tracing enabled. While it's playable, it's definitely pushing the card to its limit. The 4080 Super managed around 55 FPS, and the 4080 trailed behind at 50 FPS. Starfield, Bethesda's latest open-world RPG, is another demanding title, especially at 4K. The 5080 averaged around 70 FPS, while the 4080 Super came in at 65 FPS. The 4080 struggled a bit more, averaging around 60 FPS. Cyberpunk 2077, Phantom Liberty, CD Projekt Red's updated version of Cyberpunk 2077 is even more demanding than the original. With ray tracing cranked up, the 5080 averaged around 50 FPS. The 4080 Super managed around 45 FPS, and the 4080 struggled to maintain 40 FPS. In summary, the RTX 5080 offers a modest performance improvement over the 4080 Super, but it's not a game changer. It's not the kind of leap we used to see with new generations of GPUs. And in some cases, the performance difference is so small that it's barely noticeable. But let's not just focus on gaming. Graphics cards aren't just for playing games anymore. They're also used for a variety of other tasks, such as video editing, 3D rendering, and AI development. And in these areas, the RTX 5080 may offer more compelling improvements. For example, the RTX 5080 features improved tensor cores, which are used for AI acceleration. This can lead to faster performance in AI-related tasks, such as image recognition and natural language processing. It also features improved RT cores, which are used for ray tracing acceleration. This can lead to faster rendering times in ray-traced applications, such as video editing and 3D modeling. Ultimately, the RTX 5080 is a decent card, but it's not a must-have upgrade for most gamers. If you're currently using an RTX 3000 series card, you might see a worthwhile performance improvement. But if you're already using an RTX 4080 or 4080 Super, the upgrade is probably not worth the money. And that, my friends, is the bottom line. The RTX 5080 is a decent card, but it's not the revolution we were hoping for. It's a modest upgrade that's propped up by DLSS and marketing hype. And it's a sign that NVIDIA is starting to coast on its dominance in the GPU market. The RTX 5080's release may lead to lower prices for 4080 and 4080 Supers. That's a win for consumers. NVIDIA may be making the same mistakes as Intel. Hopefully this will create opportunities for other companies like AMD. Only time will tell.
If you enjoy this video, please like, share, subscribe and hit the bell to the later update from my channel. Thank you for watching till the end and see you in the next video.